Hello everyone, welcome back. Hope your lunch was good. Now we keep going with the talks. This is Matthew from Holochain, and guess what? Is going to talk about Holochain.
Thank you. So Holochain is a new way of building and running applications, truly peer-to-peer apps, meaning that they run entirely on the devices of the users themselves. So we don't use web servers, we're not using mining, there's no cryptocurrency needed. That's not to say that you can't create cryptocurrencies, it's just that you don't need to use cryptocurrency in order to run a Holochain app. So essentially this is a game, this is an application that gets run by the participants of the game. It's a pattern, not a platform. How many of you have paid your HTML bill recently? None of us, right? Because it's not a platform, it's a pattern. Well, Holochain is kind of similar. It's a way that people can build applications and then run them with the others who also want to participate in that app. Each app has its own members, its own storage using the devices of those members, its own namespace, and its own validation rules. What does that mean? That means that there's not one big holochain. This isn't like Ethereum, where there's like one big single blockchain. Each app is its own separate social space. If you and me and you are running peer-to-peer Twitter together, we are running that application using our devices collectively. If these folks are running a peer-to-peer version of Uber, that's running completely separate. Now, I might be participating in both of those, but they are their own separate spaces. They're their own separate applications. Today on the internet, we generally treat applications as if they are places, right? How many of you feel pulled in 40 different directions each day by your phones, pinging you constantly? I know I do. That's because we run to Facebook and then we come back out. And we go to Airbnb and we come back out. We go to email and we come back out because they are each different places digitally that we run to. It's how we think of applications today. This is problematic from our perspective. It's not just that they're different places, it's also that each of those applications, in order to run, needs web servers. And because they need web servers, they basically need a business model to support at least those hosting costs, right? And so each of those application places have an incentive to distract us and addict us, right? They're trying to ping you with notifications and pull you into that place, regardless of whether that works for you in your life. Well, we're trying to do something a little different. We're trying to create applications as grammars. Not just grammars, but opt-in grammars. Now most of you are going, grammars? What the hell are grammars? Right? Well, a grammar. Information is always in form. Right now I'm speaking, you're hearing me. Why? Well, we're using the form of sound waves, right? And you're able to experience that sound because your eardrum is flexing, it's vibrating. Your body is changing shape when that sound wave hits your eardrum. And the fact that you are transformed enables you to experience that information. In fact, the only way that we can experience information is when we experience transformation. Kind of interesting, right? Your body literally has to change shape in some way for you to notice that an event had happened. You actually have to have the ability to notice that particular form of information. So if I were deaf, if somehow I was born without an eardrum, I may be able to go into a club and feel the bumping bass in the nightclub, but in conversation, I wouldn't necessarily have the ability to notice those fluctuations of sound waves with enough fidelity that I could extract meaningful information from it. I would be deaf. So we can only experience information when we experience transformation. If I'm able to express information of a particular form, right now I'm using my vocal cords to express sound waves, and you're capable of receiving information of that form, you're hearing those sound waves, then we have a shared grammar. We've got some ability for state changes on me to result in state changes on you. There's a graphic that you guys have seen 1,000 times, right? Paul Barron, centralized, decentralized, distributed networks. These are all networks, and I'm going to take this stuff in a slightly different direction. All of them are networks, meaning that each of them have individuals communicating with some grammar. They're able to send information in some form. And in this one, they all have to talk to a single source. Here, there's a handful of sort of supernodes. And in a distributed model, everybody can sort of talk to everyone else. But all of them have a shared grammar. In a network, agents are speaking a shared protocol or a set of protocols. But an ecosystem is different. In an ecosystem, agents are able to bridge between protocols and can transform signals that are shared on one carrier into signals shared on a different carrier in a different grammar. So we're going to do a quick demonstration here. Can I have everyone close your eyes except for these three? Okay, you three, keep your eyes open. Everybody close your eyes. Okay, you three. How many fingers am I holding up on the count of 3? 3, 2, 1. Okay, everybody else, you can open your eyes. How many fingers was I holding up? 2, right? You felt like they didn't collude that quickly, right? What did they do? They were able to transform light information into sound, spoken as English. You all can hear, and so even though you didn't have access to that initial form of information, you were able to delegate some of your sense-making to them. Now, there's a trust issue there, right? What if they lied? I tried to handle that with the whole having them all three speak at once. But they were transforming information from one form into another, thus making it available to you. So they transformed light into sound. I mentioned that today the internet puts applications at the center, where we're trying to turn the internet inside out by putting humans at the center. We're trying to make it so that individuals are able to bridge between different grammars. Just like they were able to bridge between light and sound, we're trying to enable individuals to bridge between one application and another application without there having to be some top-level planning amongst the developers, without there having to be an API that was written. Anything that one individual is able to experience in one form, they can express in another form. So again, anything you can receive in one form, you can then transform and express in a different form. Thus, they can combine different applications or grammars and can bridge between those grammars. Now, right now, this is like, okay, well, why does this matter? At one level, what we're trying to do is mimic some of the patterns that exist in nature. So, right now, the world's kind of crashing in a variety of ways. Everybody sort of feel like this is sort of what's going on? Yeah. And we've got politicians all over the place that are tough talking and saying, I'm going to go take care of it. You know, they're pretending like it's a zero-sum game and somebody else has been stealing their cookies. But that's not what's going on, right? That's good for trying to win a political race, but it's not actually the problem that we're facing. The problem that we're facing is that innovation is occurring so quickly because we're such a big community, and the internet and information technology has made it so that when somebody comes up with a new insight, someone else is able to build on it the next day, not 20 years later. And then somebody else is able to build on that. And so the pace of change has picked up to such a speed that none of our institutions can keep up. The hierarchies that we rely upon for organizing business and organizing government aren't able to keep pace with that incredible innovation that's going on around them. And so we're basically drowning in this world of change because our institutions aren't capable of adapting. The ways in which we coordinate our efforts are basically handicapped by a learning disability that is based on the fact that all of those patterns of coordination, at least the ones for business and government, are centralized. They've got a bottleneck for the processing of information and the making of decisions. Well, nature has some very different patterns that it makes use of. Right? Our goal with Holochain was, hey, can we enable humanity to coordinate in ways that are actually highly adaptable? But fortunately, we didn't have to invent it from scratch. We figured we could piggyback on billions of years of research and development done by nature. Nature's figured out some patterns that are really highly adaptable, but they look very different from how we currently structure human coordination. So I mentioned this whole bridging between spaces is better for individuals and better for communities, but I'll talk a little bit about how Holochain is different from blockchain. Right? We've got chain in our name, so we sound like blockchain, and we were one of the more successful cryptocurrency projects this year, our ICOs, though our ICO actually wasn't for Holochain itself. It was for the first big application built on Holochain. It was for a web hosting marketplace called Holo, confusingly. Blockchain comes out of Bitcoin, right? And Bitcoin came out of the cypherpunk community. What were they focused on? Well, the cypherpunks were focused on freedom from constraint by others. I want to be able to interact with this guy without the government whacking me with a stick, right? That's a useful thing. They wanted freedom from constraint by others, and they were worried about this guy actually being the government. Okay, that's an important thing. It's not the only problem in the world, but it's an important one. That shifted to being expressed as essentially digital anonymous cash, and Bitcoin was able to deliver on this. And its solution, the key thing here is anonymous. What that does, this was in order to solve the, hey, I don't want this guy whacking me with a stick problem. But what it did was it took many of the tools that are key to coordination off the table. It took identity. It took memory off the table. It took an ability to build up a relationship over time and be able to know that your risk was lower with this party than with somebody else. It took that ability to exercise discretion off the table. But they were able to pull it off by having every full node keep track of every action that anyone has taken. We're familiar with this? Global consensus, you've heard of it? Yeah. What were the problems with global consensus? Well, we've been facing them for a little while now. You heard about some of those earlier with the ticket example. Scale, right? It's hard for this to handle high volumes of transactions. The cost is high because everybody has to keep a copy of everything. Plus you have the whole competitive mining, at least in a proof of work context. And the speed, it tends to be slow. Because we're all together now. Everybody, we're going to take a step. Ready? Okay, everybody, 3, 2, 1, step. Okay, we're going to take another step. 3, 2, 1, step. And that's how fast the community is able to move. That's pretty slow. It's everybody moving all together at once. We had a different goal, and so we came up with a different architecture. Our goal was not freedom from constraint by others. It was freedom to constrain ourselves. It sounds weird, but what do we mean by it? Well, a card game. How many of you have played cards at home with friends? How many of you hired a referee? What? How did you pull it off? Well, it's easy. We each held a copy of the rules in our heads. Yeah, we might have had it in a book too, but we had the copy of the rules in our heads, and we can actually change those rules every hand. Often when I'm playing cards at home with friends, the deck gets to me and I'll go, all right, 3 wilds, 2s, 3s, and 4s. And then everybody else at the table will complain, no, not 3 wilds, and all right, 2 wilds. But we update our mental model, right? Everybody knows, okay, 3 of a kind beats a pair, or whatever the game is that we're playing. And if somebody does something that's not in accordance with those rules, the first person who sees that problem goes, hey man, it's Billy's turn. You're not supposed to pick up a card yet. What are they doing? Well, they're doing 2 things. They are, 1, taking action. Hey, they're trying to attack the problem. And 2, they're signaling to others. They didn't just whisper it. They pointed out to others, hey, there's a problem here. We call this an immune system response, right? this immune system response is also how our bodies handle threats. The white blood cell in your body shows up and it sees an infection. And it goes, oh, and it signals to others, hey, there's a problem here. And then it moves to take action. Other white blood cells show up, they go, oh man, there's a problem here. They signal to others, move to take action. And this happens over and over and over again until that problem is overwhelmed and the threat goes away. At which point there's new white blood cells showing up going, hey, where's the problem? Right? And they don't signal to others and eventually the inflammation goes down. Your body doesn't have a CEO. There's no CEO cell issuing orders. Every cell has its own copy of the DNA. It has its own copy of the instruction set. It's actually a really big instruction set. I saw a TED Talk recently about the human genome, and they had a whole 3 shelves of books that was just what is basically inside the DNA of what's inside of each cell. That's how much it took to print out the entire genome, right? It's huge. But each cell has its own instruction set. And it's not getting orders from others, it's paying attention to its local conditions. Right? It's experiencing these resources, this problem, this thing, and it's becoming a blood cell, or it's becoming a bone cell. If you want to play this game, so in other words, they've got some shared rules. There's nobody acting as referee. Just like with cards, if you want to play this game and I want to play this game, we shouldn't need anyone else involved. We should be able to maintain the integrity of this game without having to rely on some outside party, whether that's a bank to make sure the records are right, or a bunch of miners that are competing to ensure that the records are right. We should be able to do it without somebody else. That was our goal. We call this mutual sovereignty. Mutual sovereignty, you might be most familiar with from how we think romantic relationships should work, right? If this is working for you and it's working for me, hey, we can keep doing this. If it stops working for you or stops working for me, we can break apart. We don't have to keep doing this. This is actually the foundation of all biological systems. All of the biological systems that we see out there are basically mutually sovereign systems. If the dance, the larger dance that's being done, doesn't work for that one cell, it goes away. And if it's not able to persist and the organism is dependent on that, this whole thing breaks down. So again, like I said before, we think of this pattern as an immune system response. It's how our bodies handle threats as well. As soon as one participant notices a problem, they move into action and they notify others. What's the big advantage of this approach? And this comes back to our larger why. I'm going to talk about how bees explore territory. So there's a phrase that we use, which is holographic storage. I'll go into it in just a second. But the basic gist is, if you have a photograph, if you took a photograph of this scene right here, and you cut out this part, so the part that had me, you wouldn't see me anymore, right? I wouldn't be in the photograph. But if you take a hologram of that same scene, and you cut out that side, but you walk around over there, you would still see me. You would see me from the perspective that this half of the film, the remaining half, sees me from. But I would still be in the image. If you cut it again and again and again and you have just a little corner, you would still see me, but just from the perspective that that part had seen me from. The idea here is that each part perceives the whole, but from its own perspective. Each part perceives the whole, but from its own perspective. I like to think of this as we are scarred by our own experiences. Right? Where is language held? Does it live in a dictionary? No. If it did, we couldn't be having this conversation right now because there's no dictionaries here. Language is held holographically. It lives inside of you, and it lives inside of me. We each have our own copy, essentially, of the English language, but it's a result of the experiences that we've each had. Do we have identical copies of English? No. I'm a surfer. I've got different experience, I've got whole jargon related to surfing that you might not be familiar with. And there are many mathematicians in this room who have jargon related to Petri nets and other parts of category theory that I'm totally clueless about. But we don't need to have perfect overlap as long as we have enough overlap that we're able to communicate. So bees. How does a beehive explore territory? Well, do they take a vote? No. Do they send everybody to go explore? No. Each bee goes off on its own, and it's keeping track of its own state. Did I find pollen yet? Did I not? If the bee finds pollen, it comes back to the hive. It does a little dance. Other bees see it do that dance. That lets them know, hey, there's some pollen over here. They go over there as well. They find pollen, they come back, they do a dance. And pretty soon, the entire hive may be harvesting the fruits of this one bee's find. But what would happen if that bee didn't find pollen? Well, it went off, didn't find anything. Should I go a little further? Sure. Didn't find anything. A little further? Sure. Didn't find anything. Wasn't able to make it back. Well, that's a bummer. We lost a bee. But life goes on. What would happen instead if the entire hive had to go and explore that territory? What if we had to use a consensus kind of approach to this? Well, if they found pollen, it's great. But if they didn't, it would be an extinction event. We'd lose the entire hive. If the only way to explore new territory is by putting everyone at risk, then any failure might prove catastrophic. Holographic storage is nature's preferred pattern for data storage and social coordination. Why? Because it gives a community the most amount of learning in context for the least amount of risk. Hey, one little bee is getting put at risk to check out this territory, but if they find something good, the whole community can benefit. And that allows that community to be exploring lots of different territory simultaneously, just like it allows us to explore lots of language territory simultaneously. People are able to be coming up with new words to describe things in math, while other folks are coming up with new words to describe things in surfing, and cars, and all sorts of other spaces. Holographic storage is the key to adaptive capacity because it enables a community to get the most learning for the least risk. It's how we do language. It's why language is so highly adaptable. It's how we do culture. It's why culture is so highly adaptable. Right? 10 years ago, was your grandma willing to go spend a night at a stranger's house for 30 bucks? No way. But then her neighbor's friend's kid tried Airbnb and said it was great, and then her neighbor's friend tried it, and then her neighbor tried it, and then eventually she was like, oh, this sounds great, and she tried it. It propagated holographically. Culture is held inside of our brains and bodies about the expectations about what's appropriate. So it's how we do language, it is how we do culture, it's not yet how we do digital communication. And it's not yet how we do collaboration at scale. I'll talk briefly about progressive trust. And can I get a quick time check? How am I doing there?
5 minutes.
Okay. So progressive trust. This is how trust works in the real world. We don't meet a stranger and go, okay, I'll marry you. Right? We take small risks. Right? We make eye contact. We see how that goes. Depending on how that goes, you might go, hey, I'm Matthew, right? And we see how that goes. And little by little, each person is making themselves a little bit vulnerable and seeing how it works out. They're taking a small risk. And as they gain a better understanding of the situation, the next risk they take, which is, again, a small risk, is a better informed risk. Over time, this enables us to get to a fairly deep relationship. Some of the ways that we can make it easier for that other person to take a risk with us is by making ourselves more vulnerable. So when I introduce you to my mom and dad, I've just made myself more vulnerable, right? If I treat you badly now, you know who to go talk to. You can go back to the rest of my community and it's going to have repercussions for me. Me making myself vulnerable in that way makes it easier for you to take a risk with me. We do this all the time. We regularly engage in these trust-generating dances. For instance, the mating ritual that we just talked about, but also job applications. When you apply for a job, you often not only put your credentials, but you'll actually put contact information for people that you've worked with before. Both so that they can investigate you, but also so that if something goes wrong, they know who to talk to. You're making yourself vulnerable in a way that makes it easier for them to take a risk with you. If my costs significantly outweighs any benefit that I would gain, you can be confident that I'll behave well. In Holochain applications, we're making use of some distributed patterns for enforcing the rules of that app. But every app is different. The social context of that app is different. The consequences of somebody cheating when I'm trying to tell my sweetheart to pick up milk on the way home from work are different from the consequences of somebody cheating when I'm trying to send $30 million. And as a result, the kind of security measures that I'm going to need are going to be different. So we're not doing a one-size-fits-all security model. We're actually trying to enable the people who are building Holochain apps to customize the security model for the specific social context that they're facing. Single games versus multiple games. The basic gist here is, in game theory, one of the key things has to do with propagation of information. If I'm able to make information propagate, or if I'm able to constrain information from propagating, we can start to influence the behavior of actors. Part of the reason that hash functions are used in blockchain has to do with this, right? People not being able to predict what the hash is that will generate the winning, or what the piece of content is that will generate the winning hash. In single games, you can structure something. How many, you're all familiar with the prisoner's dilemma, or something along those lines? Okay. You can structure a thing where people are going to screw one another over. But if you have multiple games, if you're actually able to learn something about how someone behaved in the previous game, I can punish you for having screwed somebody else over. And if you have 3 games in a row where the next guy can see whether or not I punished you, you actually get a different thing which we call altruistic punishment. If I don't punish you for having behaved badly, the next guy is going to punish me for having failed to punish you. And suddenly the cost-benefit analysis within a single game shifts dramatically. It makes it so that it's actually much more costly to defect than to cooperate. Well, the ability for individuals to make themselves vulnerable by exposing others to information from different social contexts makes it much easier for them to collaborate. So our focus here with Holochain is actually to create trust-generating social spaces, not trustless social spaces, but trust-generating ones. That doesn't require real-world identity. It doesn't require government ID. But based on this social context, in order for you to feel comfortable taking some risk with me, I'm going to go and look for the other parts of my life where I can find the information that you need in order to feel comfortable. I will make myself vulnerable in specific ways. I'll put enough skin into the game that you feel like, yep, I can trust that. Now that could be cash on the table in the form of an escrow, but it could also be reputation. It could be me introducing you to other people in my life so that you feel like, yep, he's not going to screw me over in this context because it would cost him way too much in these other contexts. So with that, I will leave it. If you have questions for me, feel free to come up later. I'm here with John Paprocki, also Pop Rocks. Thank you very much.